Please subscribe the channel and don't forget to click the bell icon.
Bismillahirrahmanirrahim. Welcome to Botanica. So previously we were discussing about the various tropic movements which are occurring, either it is because of the gravity or it is because of the light. So either it is phototropic response or it is geotropic response or gravitational response. So now we are talking about a tropism, a third type of tropism, a movement or the growth movement of the plant which is occurring towards the external stimulus, and here the stimulus is water. So previously either the stimulus in the phototropism we have seen the stimulus is light, and in gravitropism or in geotropism the stimulus or the external stimulus which we call paratonic stimulus, which we call that is gravitational force of the earth. So here we are talking about the hydrotropism, as the name indicates that hydro means water. So that's why it is called as hydrotropism, the movement of the plant organs towards or away from the stimulus of water. So here this particular growth response of the plant organ is to the stimulus of water. So like both of the tropic movements which we have discussed previously, either that was phototropic response or it was geotropic response. So here hydrotropism may be positive hydrotropism or negative hydrotropism on the basis of the movement of that particular plant organs towards or away from the stimulus. So as far as the roots are concerned, the roots of the most of the plant species show positive hydrotropism. So as we see the roots of the plants always grow towards the stimulus of water. If water is very deep in the soil, so always root try their best to reach that particular water table and to absorb the water from there. But as we have seen the stem, we can say that it is a negatively hydrotropic, we said that it acts oppositely to the roots. So roots of plants grow into the soil with abundant water. So we have seen in the tropic response there is not only the stimulus, it is also the concentration of that particular stimulus. For example, if we have a light, so if there is a light, तो हमारे पास अगर लाइट का स्टिमुलस है तो लाइट जिस तरफ ज्यादा होगी उस तरफ जो है रिस्पांस प्लांट का ज्यादा होगा, उसी तरह भी प्लांट के ऑर्गन की मूवमेंट होगी. इसी तरह जब हम बात करते हैं हाइड्रोट्रॉपिज्म की, तो यहाँ पे भी हमारे पास सेम केस है. इफ वी हैव वाटर टेबल, फॉर एग्जांपल इफ वी हैव plant root and water table is present, but we have two sources of water, two sides of water. एक साइड के ऊपर वाटर की जो कंसंट्रेशन है, वाटर जो है वो ज्यादा है, दूसरी साइड पर वाटर कम है, तो प्लांट की रूट जो है वो उसी तरफ ही जाएंगे जिस तरह वाटर की कंसंट्रेशन वाटर इज इन abundant form. So how this hydrotropism occurs, but we don't know about the actual mechanism, but we know that what are the various pathways, what are the initiators, how the different organs of the plant act as for the absorption of that particular water. But this is the simple hydrotropism. We don't know much about, or we are not going to discuss much about it. What are the causes, how the mechanism is perceived, as we have seen in the geotropism and in the phototropism. But we are going simply to define what are the tropism or what are the tropic movements. So here we have this. As we have seen, this is a plant which is growing in this particular soil, this particular area. So here if we have a soil, moist soil, here we have a soil which also contains some sort of water. We have a moist soil, and both the sides of the plant, the moist soil is present. So as there is no difference in the concentration of water on both sides of the root, so that's why a root is growing straight. So it is not bending towards the any side. Why? Because the moist soil is present on both the sides, on right and left, on both sides. Or we can say that in three-dimensional picture that root is growing straight, it is not bending, there is no curvature of the root toward the stimulus. But here we can see that on the right and left side the soil is different. So here on this side the soil is dry, the water concentration is low, but here on this particular side there is a moist soil as well as there is a source of water. So what will happen? The roots will grow toward the water, because always when towards the growth of the root is always towards the abundance of water. So moist soil is present here, but roots are growing toward the source of water. जिस तरफ पानी ज्यादा है, जहाँ पे पानी का सोर्स है, उसी तरफ ही उन रूट्स की मूवमेंट हो रही है. या सिमिलर, दिस इज द एक्चुअल पिक्चर, एक्चुअल डायग्राम. So you can't see here any sort of trees. These are the grasses, and grasses की जो roots हैं वो fibrous roots होती हैं, और ये उनकी इतनी healthy roots उन plants की हो भी नहीं सकती. So यहाँ से अंदाजा लगाया जा सकता है कि ये जो roots आ रही हैं plants की, they are coming far away from this particular. So as you can see in the backdrop, there is also a source of water. So roots are growing towards the source of water. We don't know where the trees are located, but trees are not here near with the water source, but they are present away from the water source, but they are extending their roots towards the source of water. So this is the case of positive hydrotropism, because roots are going towards the source of water to extract water as much as they can. So you have seen in the desert environment में भी क्या होता है कि plants जो हैं वो desert plants की जो roots हैं, they are very much extended form, fibrous roots होती हैं, और बहुत ही ज्यादा lengthy roots, extended roots होती हैं. और वो किस लिए कि वो इसलिए कि जिस तरफ भी ज्यादा पानी मिले, जितना ज्यादा पानी जो हो उसको absorb किया जा सके. So this is the hydrotropism, and we can classify the different plant organs, either roots and shoots, that it is either positively hydrotropic or negatively hydrotropic. So we are not going to discuss about the mechanism of hydrotropism, and now we are discussing the thigmotropism. And what is the thigmotropism? It is the movement of the curvature shown by plant organs in response to the stimulus of touch with some solid object is called thigmotropism. So this is the definition. So whenever we are talking about anything, so first we have to define that particular topic, what it is. So as far as the thigmotropism is concerned, it is the response, or we can say that, or we can define it in few words, that it is the response of plant organs toward the stimulus of touch, or to the stimulus of touch. Either it will be toward the touch of the stimulus or toward the solid object, or it will be away from the solid object. So in both cases, either of the case it will be positively thigmotropic, or it will be negatively thigmotropic. So perfect example of thigmotropic is provided by the tendrils, which are mostly present in the family Cucurbitaceae, as we have seen in the tendrils which are present in the family Cucurbitaceae, like in the simple, it is specialized, or it is modified leaf, which act as a tendril, as we seen the picture of the tendril and how this particular mechanism is occurring. So petiole and leaves of some plants also show this type of movement. So this particular type of movement is either, for example, the petiole, it will move toward the solid object, toward the touch stimulus, or it will move away from the touch stimulus, and leaves are also either positively or negatively. So curvature in such plants organ is produced by unequal growth. So as we have seen in the mechanism of phototropism, so here we have also seen that there is an unequal growth in different parts of the plant, so in different sides of the plant. So that side which is touching with the stimulus, touch stimulus, so there the growth will be slow, but the cells which are opposite side on the point of the contact, they grow and enlarge more rapidly. So that's why there is a bending or twining response. So that particular object of that particular tendril or modified leaf will twine around that particular solid object to which it is touching. So what happens here is also the concept of differential growth, unequal growth, as like we have discussed in the geotropism and phototropism. And curvature here, the bending response here is because of the touch stimulus or the stimulus of. So due to this unequal growth, curvature appears around the object, but the mechanism of thigmotropism is not clearly understood, as we have discuss the many mechanisms or pathways of other stimulus, but it may be attributed, or there are possibilities that it may be auxin or it may be ATP, which stimulates the permeability of membrane, and that due to this particular increased permeability of membrane, it will allow the entry of ions and different ions and water molecules, which will have a role in the thigmotropism. But this particular mechanism is still not clear. So as we have seen, these are the tendrils which are the modified leaves of this particular plant. So what happens? These are twining around the solid object. So these are the solid objects. So if you place a solid object at towards one side of this particular tendril, so always you have seen that you will see that this particular tendril will always move towards the solid object and it will not move away from it. Why? Because it needs support. So these tendrils act as a support. When they twine around this particular solid object, so they get a support and they grow more vigorously, more rapidly. So these are so we were talking about the curvature. So this is the curvature. So tendrils are twined around this particular solid object. So what happens? So toward the outside of this particular stimulus, to this particular tendrils, the growth is more rapid, and that side which is touching this particular solid object, the growth will be slow. So due to this particular unequal growth, the twining response is present, and this particular tendril twine around this particular solid object. So same is the case here. So on this side there is nothing as the solid object which is present towards the left side. So left side के ऊपर जो है एक solid object, एक wood का piece जो है वो मौजूद है, बट यहाँ पे कोई भी solid object नहीं है. तो आपने देखा कि जो tendril है, tendril is moving towards the solid object to get attached to it and twine to it, और अब इस plant को जो है वो support मिल गई है. So this is a positive thigmotropism. So there are some other plants which behave or which act or which behave as negatively thigmotropic. So they move away from the touch stimulus and they do not touch with each other. There are some other trees, some plants which do not touch their leaves. जब आप canopy में देखते हैं forest की canopy में, तो वहाँ पे भी ये होता है कि mostly trees जो होते हैं वो एक दूसरे के साथ touching को जो है वो टच नहीं हो रहे होते, और वो किस लिए? ताकि वो एक दूसरे के साथ उनका जो लाइट पहुंच रही है नीचे वो भी उनको पहुंचती रहे, और उनमें टच का जो स्टिमुलस है वो एक दूसरे से क्या है वो दूर रहे. सो देयर इज ए थिग्मोट्रोपिज्म, एंड नाउ वी आर टॉकिंग अबाउट, सो वी आर टॉकिंग एज फार एज दीज थ्री टाइप्स आर कंसर्न, दे आर वेरी मच सिंपल. सो देयर इज नथिंग मच इन इट. So it is the growth response induced by injury to plant organs. So as far as the traumotropism is concerned, so it is named from the trauma center, emergency center, which is in the hospital. So as far as this particular name is because of the injury, because of the accidental injury to the plant. So it is because of the injury. So traumotropism curvatures may be due to the interruption of food supply from other parts of the plant to the growing region. So what happens? So in plant there is a continuous systems of cells, continuous tissues, xylem and phloem, which are providing food to different organs of the plant. But if due to injury there is a inhibition of food, or there is a pause, or there is a disturbance in the food supply, so what will happen? These growing regions, they show a response which we call a traumotropism, or the response due to injury. So this may also be due to supply of oxygen. So as we have seen in all the tropic movements, we are also discussing the oxygen. So more or less there is a role of oxygen in every tropic response. So how oxygen is associated with it? What is the mechanism? So we are not discussing about it. So but there is no definite explanation of this response. So why traumotropism occur, how it is stimulated, and why there is a response toward the injury. So we have seen traumotropism, it is very much understandable. ये ट्रामोट्रोपिज्म में इंजरी जब होती है तो इंजरी की वजह से फूड की सप्लाई जो है उसमें डिस्टर्बेंस आ जाती है. और जब उसमें डिस्टरबेंस आती है तो प्लांट जो है वो ऐसी साइड के ऊपर ग्रो करता है, उस साइड की तरफ ग्रोथ को ज्यादा करता है, उस तरफ पहुंचने की कोशिश करता है जिस तरफ फूड जो है उसको ज्यादा अवेलेबल हो। तो इसको हम क्या कहते हैं, दिस इज सिंपली ट्रामोट्रॉपिज्म।